So combination, there is a difference between permutation and combination. Whenever the order of the arrangement does matter, that's where we do permutation. But if the order does not matter, then that is the combination problem. So the combination means order doesn't matter. So for example, let's say how many different ways you can arrange A, B, and C. So A, B, C, B, A, C, CAB, and then keep going. If this order doesn't matter, then there is just only one way, ABC, and that's the combination problem. So we're going to look some, problems using the combination and then permutation as well. We need a formula. We have a formula. We're going to use that formula. So the combination happens whenever we select items from same group. No item is used more than once, and then order of the item makes no difference. Permutation involves situation in which order does matter. So that's the difference between permutation and combination. But combination, order doesn't matter. This is one example. Let's say you want to choose 3 letters from A, B, C, D. How many different ways you can arrange them? These are the different ways: 1 group, 2 group, 3 group, and 4 group. 1, 2, 3, 4, 5, 6. There are 24 different ways to arrange 3 out of 4. So permutation of 3 letters out of 4 letters, it's a 4 factorial divided by 4 minus 3, 1 factorial. That's a formula. So it's this is 24. So there are 24 different ways to arrange them, but if order doesn't matter, then ABC and ACB, they are same thing. All these different orders, if they are same, then that just count 1 in combination. So this is 1, this is 1. If order doesn't matter, then they all are same. So there are 4 combinations. So look, very same problem, the permutation 24 and then combination just 4. So what's the formula for the combination? If you're choosing R items from n choices, then the combination of R items from n choices, this is the formula you can use: n factorial divided by n minus R factorial times R factorial. We're going to see some problems, I have assigned for you. So let's do that. Okay. Combination problems involve situation in which the order of the item makes a difference. Combination means order doesn't matter. So statement is false. The statement is false. To make this statement true, change combination to permutation, and change makes a difference to doesn't make a difference. No, this statement is false. To make this statement true, change makes a difference to does not make a difference. Yes. Okay. How do you calculate this one, which is choosing 4 items out of 7, combination of 4 items out of 7? You can use the formula, which is combination of 4 out of 7 can be calculated, which is 7 factorial divided by 7 minus 4, which is 3 factorial, and then 4 factorial. 7 factorial means 7 times 6 times 5 times 4 factorial. 3 factorial means 3 times 2 times 1, and 4 factorial, I don't want to expand that because it's divisible. 3 times 2 is 6. This 6 is gone. 7 times 5 is 35. So there are 35 different combinations if you try to choose 4 items out of 7. An election ballot asks voters to select 6 city commissioners from a group of 16 candidates. So 6 cities commissioner from the group of 16. Here order doesn't matter, so this is the combination problem. You always have to find out either that is combination problem or not. Here, no matter how you choose, the order doesn't matter. So choose how many? 6 out of 16. So this is 16 factorial divided by 16 minus 6 is 10 factorial, 6 factorial. That's the formula. 16 times 15 times 14 times 13 times 12 times 11 times 10 factorial. You stop here whenever you get the higher factorial on the denominator. 10 factorial. So this is the higher one out of 2, and you stop at 10 factorial. Cancel out. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. You divide this number by this number. I'm going to use a calculator here. 16 times 15 times 14 times 13 times 12 times 11, divide by 6, divide by 5, divide by 4, divide by 3, divide by 2. That's 8008. There are 8008 different ways to choose 6 out of 16. How many different committees can be formed from 6 teachers and 41 students? So if the committee consists of the 3 teachers and 3 students. Okay, so how many different ways you can choose a committee with the 3 teachers and 3 students? So we are trying to choose 3 teachers out of, how many teachers are there? 6 teachers. So this is the combination, because no matter which teacher, which order you put those 3 teachers, it doesn't matter. So 6 factorial divided by 6 minus 3 is 3 factorial, 3 factorial. 6 times 5 times 4 times, you stop at 3 factorial. 3 factorial means 3 times 2 times 1, which is 6. So there are 20 different ways you can choose 3 teachers from 6. Similarly, you have to choose 3 students from 41, and this is 41 factorial divided by 41 minus 3 is 38 factorial, 3 factorial. 41 times 40 times 39 times 38 factorial divided by 38 factorial times 3 times 2 times 1. This is gone, dividing this thing by 6. So I'm going to use a calculator here. 41 times 40 times 39 divided by 6, which is 3 times 2, 10,660. 10,660. So we can select 3 teachers out of 6, 20 different ways, and 3 students from 41 in 10,660 different ways. So whenever we try to form a committee from 20 and then 10,660, the total would be permutation, which is 20 times 10,660. This is the fundamental counting principle. So just multiply that by 20 different ways. So that is 213,200. 213,200 different ways we can make this committee. Okay. From a club of 25 people, in how many ways can a group of 6 members be selected to attend a conference? So the member doesn't matter, so this is combination problem. From 25, you would like to choose 6. So 25 factorial divided by 25 minus 6 is 19 factorial times 6 factorial. 25, 24, 23, 22, 21, 20, and then 19 factorial. Divide by 19 factorial, 6 times 5 times 4 times 3 times 2 times 1. This is cancel out. I'm just going to multiply this thing and then divide by this. Or I can just cancel. 6 times 4 is 6 times 4 is 24. This 4 and this 4 is gone. 5 times 5 is 25. 3 times, is there any 3? Times 7 is 21. 2 times 11 is 22. So you just have to multiply the number, leftover number on the top, which is 5 times 23 times 11 times 7. which is 8,855 different ways. 8,855 different ways you can choose. Oh, what happened here? What did I do wrong? Did I do something wrong here? From a club of 25 people, how many ways can a group of 6 members be selected to attend a conference? 6 member from 25. 25 minus 6 is 19. So 25, 24, 23, 22, 21, 20, 19 is cancelled out. 6, 5, 4, 3, 2, 1. So let me just use a calculator here. Maybe I did wrong cancellation. 25 times 24 times 23 times 22 times 21 times 20 divide by 6 divide by 5 divide by 4 divide by 3 divide by 2, and that's the answer. 177 100. I did something wrong here. I don't know what I did, but if I use the calculator, it's 177,100, and let me go back, 100. Okay, so I did something wrong before. So use a calculator, whenever you have big numbers like that. So that's all for this section.